Okay, so this is a question asked on email. This is problem 3.5.27, and they ask us to find all real and imaginary zeros of g of x. And they give us x cubed plus 10x squared plus 22x plus 48. Okay, so the first thing that you just want to take a look at when you're looking at this function is the highest power on the function is a 3, so that we know that we're going to have 3 zeros total. It's either going to be, you know, well, 2 imaginaries and 1 real, or possibly 3 reals. And so the first thing that we should do is probably identify our PQ list. So remember that P is all the different factors of your constant term of 48, and Q is all the different factors of the coefficient of your highest power. And then P over Q would be the potential real zeros that we have for the problem. Okay, so if I identify my P list, the different factors for 48, we could start with 1 and 48. There's also 2 and 24, so 2 times 24 would give us 48, and I'm doing plus or minus for all of these. Plus or minus 3 and 16, and then 4 and 12, and then 6 and 8. Okay, that's a pretty big list, actually. The Q list, thankfully, is quite small. The Q list is just plus or minus 1. So when I take and divide P over Q, then I'm taking each of these numbers in my P list and dividing it by a plus or minus 1. I'm actually just going to get this list back, the P list back. Okay, so what this P over Q list does for us, pardon me, what this P over Q list does for us is tell us that if we have a real zero, it's coming from this list. Okay, so now that's a pretty big list, so we want to try and narrow it down if we can. I'm going to use Descartes' rule of signs in order to narrow this down. If you take a look at the original function, notice that you don't have any sign changes. I mean, this is positive, this term's positive, and this term's positive. So because we have no sign changes, Descartes' rule of signs there tells us that we have essentially no positive real zeros. So remember that you look at g of x, the original function, or f of x, whatever it is, the original function to identify how many positive real zeros you have. You look at the number of sign changes. Okay, since we have 0 sign changes, we have 0 positive real zeros. If I want to identify how many possible negatives I have, then I need to evaluate g of negative x. Okay, and we'll do that. But before we do that, just notice what this piece of information does for us. If we have no positive real zeros, that actually eliminates half of our P over Q list. We're not going to try any of these positive zeros because there aren't any. Okay, so we don't have to try positive 1 or positive 48 or positive 2 when we go to the synthetic division step. We just ignore all of those. Okay, let's take a look at g of negative x. So when I plug negative x into my function and evaluate the function, again, we're looking for sign changes. I'm just at the moment using Descartes' rule of signs. So this just becomes negative x cubed. This is plus 10x squared minus 22x and plus 48. Okay, maybe I should write that down, because this is kind of an aside. You know, this is kind of a side note of working this problem. You don't actually have to do this. It just helps give you some additional information. So notice here that I have actually 3 sign changes, which Descartes' rule of sign tells me then that I have either 3 or 1 negative real zeros. Now, we actually didn't need to do that, because if we have 3 zeros, you know, the fact that we have a high power here being a 3 tells us that we have 3 zeros. So you're either going to have 3 real zeros or you're going to have 1, because if you've got imaginary zeros always happen in conjugate pairs. So, you know, if you've got some imaginary zeros, you've got 2 of them. You're never just going to have 1. So if you got 2 of those, then the 1 left over would have to be the real. Okay, so, but this tells us, you know, let's try some things from the negative list. Okay, so I'm going to try negative 8 in synthetic division simply because I know it works, and that way I'm not wasting a lot of time on this video. But, you know, obviously if you don't know that negative 8 works, then you're just going to try things. You're going to pick some of these negative zeros, do the synthetic division on them, and if it doesn't work, then you're going to cross them off your list and try something else. Okay, so I'm going to try negative 8, and I'm going to use the coefficients of I'm using synthetic division now. So I'm getting that 1, 22, 1, 10, 22, and 48 are the coefficients of my function, the terms in my function. And the way we do synthetic division is we're going to bring down this first term right here. And then we're taking 1, this 1 times negative 8. So it's 1 times negative 8 would give me a negative 8. I'm going to put that negative 8 right there. And then I'm adding these two. So 10 plus negative 8 here is going to give me a 2. And then 2 times negative 8 is negative 16. And we just keep doing this. And 22 minus 16 is 6. And 6 times negative 8 is negative 48. When I add these two, I get a 0. This 0 right here, this tells me, because I have a remainder of 0, that actually tells me that negative 8 is a 0 of this function. Okay? If I get something other than a 0 right here, if I get any other number, then it's not. And you just cross it off your list and you keep going and using the synthetic division until you find a 0. Okay? So this tells me that x equals negative 8 is one of the zeros. Okay, good. Well, we have 2 more to find. And what we're going to do is we're going to work with these coefficients and form what's called the depressed equation. And the depressed equation is taking these as coefficients and we're diminishing the power by 1. So, you know, we started with an x cubed. When I've done synthetic division, if I have x equals negative 8, that's a linear factor that I'm taking out of it. Okay, so this is, the coefficient here would be 1x squared. I would have plus 2x and plus 6. And actually, just to be complete here, g of x now factors into x plus 8 times this factor right here. This x plus 8 factor would give us this x equals negative 8 when we set it to 0. And what we're concerned with now is taking this x squared plus 2x plus 6 and setting it to 0 and then solving that. Okay? Pardon me, I think I have allergies today or something. Anyway, so we're going to now just use the quadratic formula on this. If it factored, then we would factor it, but it doesn't, so we'll use the quadratic. So this is going to be x is a negative 2, that's negative b. Here, why don't I identify? A is 1, b is 2, and c is 6. Okay, so when we plug that into our quadratic, x is a negative 2 plus or minus, we have b squared, so that's 2 squared, minus 4 times a is 1 and c is 6, and this is all over 2 times 1. Okay, so this gives us a negative 2 plus or minus the square root of, this is 4, minus 24 all over 2, and then just simplify under the radical. We have negative 2 plus or minus the square root of negative 20 over 2. This can simplify. Square root of 20 has a 4 and a 5 in it, so I'll just write it out for you. I'm going to just call it a negative 4 times 5. And then the square root of negative 4 is actually 2i. So, okay, so this becomes negative 2 plus or minus 2i square root of 5 over 2. That's taking the square root of negative 4 right here and simplifying it to a 2i. And then this 2 is going to divide each of these pieces right here. So this becomes actually a negative 1 plus or minus I times the square root of 5. Okay, so we have 3 zeros. We expected to find 3 zeros. Here's 1. So we have 1 real 0, and then we have 2 imaginary zeros. Okay?